Today's video is on related rates. This video will focus on one related rates problem, and it is intended to help you translate written problems into mathematical problems. So here's the problem we'll focus on. Suppose a point A starts at 0,20 and moves in the positive x direction at a speed of 30 units per second. Point B starts at 30,20 and simultaneously moves in the negative y direction at a speed of 20 units per second. Both move for a total of 1 second. How fast is the distance between the 2 points changing? This is a fairly standard related rates type problem. Now let's just go over to Desmos and look at this problem specifically. So here's the point A, here's the point B, and you see how they're moving. A is moving to the right, B is moving down. We can construct a line segment that represents the distance between these two, and you can see as they're moving, this line segment is changing length. Okay. So as is the case with any problem in this course, we need an accurate diagram to help us understand the problem. Here we have the situation. Here's point A, here's point B. A starts at 0,20 and moves along this line. B starts at 30,20 and moves down along this line. And I'm going to start labeling the diagram. This is the distance we'd like to find, so we label it D. And I'm going to call the distance between where A starts and where it is currently by small a. And the remaining distance A has to travel is 30 minus A. And you can see that if you add these two together, you get 30. Similarly for B, the distance between where B starts and where it is currently is small b. And again, this total distance is 20. Okay, now we can use Pythagorean theorem to come up with an expression for D. It's just d squared equals 30 minus a squared plus b squared. One thing you have to notice is that A and B are changing at different rates, but they're related in some way. What I mean by that is A just can't change independently of B. They are both dependent on time. So A and B are not independent variables, they're dependent variables, dependent on time. Now since the speed of A is 30 and the speed of B is 20, we have these expressions. This A is a function of t, and we can write it as 30 times t. And this B is also a function of t, and we write it as 20t. So we can revise our D and sub in our expressions for A and B. Now you look, we have only one variable here, which is perfect. That's exactly what we're looking for in this course. So when we're trying to find the rate of change of the distance between the 2 points, what we're looking for in terms of calculus terminology is the derivative of capital T with respect to t. Now we can find this using a multitude of approaches. We could square root both sides and use the chain rule, or we can try using implicit differentiation. So when we differentiate this implicitly, take the derivative of the outside, which will give us 2 times the inside, so 2 times d, times the derivative of the inside, which is dd dt. And now I can use the chain rule on the right-hand side. I bring this exponent down, then I multiply by the derivative of the inside. And the same here, I take this exponent down and multiply by the derivative of the inside. Okay, now I can simplify and I get this expression. I'm not quite done yet though. We need to isolate the derivative dd dt, which is what we were looking for originally. Well, we can do that by simply dividing both sides by this 2d. We have an expression for d, and that's given by just the square root of this. So in all, we have dd dt is this function divided by 2 times the square root of this function. And that's all there is to it.